We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello all, myself KULKARNI, Assistant Professor in Electrical Engineering Department at PATEL Institute of Technology and Research Center, UMRAKH, BARDOLI. Today we will be discussing time domain analysis of first order circuit. This topic is a part of chapter 1 DC circuits that comes in subject basic electrical engineering and subject code is 3110005. So let us have a glance in the syllabus that is prescribed by GTU. So as you can see, this is the syllabus which is prescribed by GTU, where we will be discussing part 1, chapter 1 of DC circuits, and today we will be discussing mainly on this last topic of time domain analysis. We have already studied this much portion, and the left is first order circuits. So first of all, what is first order circuit? So whenever you solve a resistance and inductance circuit with a supply, or you solve a circuit with resistance and capacitance that is connected with the supply, so you will end up with the equation which will be having the equation in the form of di by dt or dv by dt. So these two terms are first order expression, mathematical expression, which represents that these two circuits are having first order equations. So that's why here the term first order RL and RC circuit is mentioned. Now we will be studying the time domain analysis. So what is the time domain analysis? So time domain analysis is the analysis of a RL and RC circuit with the time constant that is involved when the circuit is excited with a DC source. Then RL and RC takes some time to reach its maximum value, either current or voltage. Similarly, when you discharge this circuit, it takes some time to completely discharge from initial condition to final condition. So these two conditions make time domain analysis of first order RL and RC circuit an important topic to be discussed. So let us begin. First topic is charging of RC circuit. So in this case we will be studying the charging condition of RC circuit. So over here you see a figure. So initially switch is open, so no current will be able to flow to charge capacitor. Consider initially capacitor is uncharged. Uncharged, it means capacitor voltage will be 0 volts. Now this VC is to be charged, so we will close this switch. Okay, this switch is closed, so this will become like this. Okay, so now we consider that this switch is closed at t equals to 0 second. So we can say that at t equals to 0 second, capacitor voltage is also 0 volts, because it is the property of capacitor that it will not allow sudden change in voltage. So at t equals to 0, Vc is equals to 0. So this becomes our initial condition. Gradually, as the voltage will rise because of the flow of current, so IC is the charging current that will rise the voltage across capacitor, and this IC is given by equation supply voltage minus capacitor voltage divided by the resistance. Now this IC is nothing but C dVc by dt, and this equation is same as it is. You just need to separate variables and constants, which will give us this equation. This equation is further solved by integrating them both the sides, which will end up with this equation. Now, when you integrate this, we know that the answer will be minus ln times b minus vc, that will be equals to t by rc plus c. One thing to be taken care is this c is the constant. This c is the constant which is to be found, constant value, and this c is the capacitance of the circuit. So don't confuse between the two terms. We can now find the value of constant using the initial condition. So we know that at t equals to 0, this Vc is equals to 0. So you will get C will be equals to minus ln V. So for this closed circuit, now we can find the capacitor voltage Vc and the capacitor current or charging current Ic. So now place the value of C over here. You will get the answer to be ln times V minus Vc equals to minus T by Rc plus ln V. So this is very simple because when you keep the value of C over here, it will be, the equation would be like this, minus ln V minus Vc, this will be equals to T by Rc minus ln V. So we take this negative sign on this side, so it will become this way. This negative sign is taken over here, so this T by Rc will be negative and ln V will become positive. I hope that you have understood it here. Now we'll continue further and we find that ln V is taken on the left hand side, and this, when we take this ln V on the left hand side, it comes to the denominator because it is the property of logarithm where difference of two logarithm terms is nothing but the ratio of the logarithm terms. So from here you can find the value of capacitor voltage by taking this natural log on the right hand side, because this is having base E. So when you take this on the opposite side, you will get V minus Vc by V will be equals to e raised to minus t by Rc. So if you solve this further, you will get that Vc is equals to V times 1 minus e raised to minus t by Rc. Now further, you can find the value of Ic. We know that Ic is equals to C into dVc by dt. Now here C remains constant. We have to derive this equation, that is Vc. So when you derive this, so let us try to derive this. So it will be d by dt of Vc will be, it is V minus V into e raised to minus t by Rc. So if you solve this, you will get C multiplied by this minus sign because dV by dt is 0. So you will get this minus sign. This is d by dt of u dot v. You know that d by dt of u dot v is equals to u dash v plus v dash u. If you do this, so you will get that v dash differentiation of v with respect to t is 0. So you will be getting answer for this term only. So it means you have to find this answer. So it means that you will get minus v into minus t by rc into e raised to minus t by rc. This will be the answer. Now if you see this minus and this minus will give us plus, this C and this C will cancel, and so this will be not minus T, it will be minus 1. So minus 1 by RC. So you will get that. So let me solve this again over here. This much portion, I think it should be solved again for solving your doubt. So you will get that it will be C times multiply by minus B multiply by e raised to minus T by RC, and this e raised to minus T by RC differentiation will give us minus 1 upon RC. So if you do this, this C and this C cancels, this negative sign and this negative sign will give us positive sign. This will be plus V by R e raised to minus T by RC. Okay, so this will be the equation for IC. I hope that you have understood. This plus V by R can be written as I0 e raised to minus T by RC, where I0 represents the maximum current, that is V by R. So let us take the analysis part of this charging case. So conclusions drawn from the derivation is that initially switch is open, so capacitor voltage is 0 volts, and I0 is V by R, that will be the maximum current. After some time, this capacitor voltage is equals to the supply voltage, where this V is the maximum voltage up to which capacitor holds charge. On deriving, we found that BC is equals to this equation, where BC is equals to V into 1 minus e raised to minus T by RC, and this T RC can be replaced by tau. Okay, this is called as tau. Tau is nothing but the time constant. Okay, this is nothing but the time constant. And we also found the value of IC. So IC was equals to I0 e raised to minus T by tau. We can find the graphical representation by keeping different values of this T. That is, we can replace it by tau, 2 tau, 3 tau in both the equations. We can find the graphs. The analysis can be observed. So let us see the analysis. So first characteristics will be for DC, and the second will be for IC. Okay, so here we have a graph. So over here you can see capacitor voltage rises gradually, and as soon as capacitor voltage rise, so the current will be decreasing. So here I have taken different instances T, tau, tau, 2 tau, 3 tau, 4 tau and 5 tau. You can see that at 5 tau approximately capacitor voltage is equals to the supply voltage. So you can say that 5 tau is the time constant at which capacitor charges fully, and this is the tau, that is time constant. It is the time at which capacitor voltage is charged to 63.2%. So over here I have mentioned time constant is defined as time required for capacitor voltage to rise from 0 to 0.632 or 63.2% of its final value. Means this is the final value and it has reached 63.2%. Similarly, you can also write for capacitor current or charging current, where it starts from maximum value, that is V by R. It starts from maximum value and it decreases to 36.7%. So you can write that while charging, it is 36.7% from its initial value. I hope that you have understood till here. In the next case, we will be discussing discharging case of RC circuit. Thank you.